Hello students, welcome back to the virtual class. In the first lecture, we have discussed about the importance of the solids, their general characteristics, types of solids that were crystalline and amorphous, and the basics of these amorphous solids. Hope so, all of you have understood and would have been liking this teaching method. Now let us study today in this lecture about the crystalline solids and its types, crystal lattice and unit cell. In our previous lecture, we have discussed about what are crystalline solids. Those solids which are having long range order of constitutional particles are known as crystalline solids. They are having sharp melting point. They are true solids. They are anisotropic in nature. The example of crystalline solids were like sodium chloride, silicon carbide, etc. All of us knows that if any substance on freezing can be converted into solid form, that is by lowering the temperature of the gaseous or liquid state, they can be brought into solid form. Does all the substance have similar arrangement and characteristic when this type of solids are formed? No, these crystalline solids have different characteristics and the properties when they are converted from gaseous or liquid state to solid form, or even when they are in their actual solid states. That is the reason why these crystalline substances are classified into different types. They are classified in 4 different types: molecular solids, ionic solids, metallic solids, and covalent solids. Specifically, molecular solid is furtherly classified into 3 subcategories: non-polar molecular solids, polar molecular solids, and hydrogen bonded molecular solids. We will be discussing each of them one by one in the detail. The first type of crystalline solid that we are going to discuss is about molecular solids. Molecular solids are those compounds which shows some additional forces of attractions like van der Waals forces and hydrogen bond along with covalent bonds. That is the reason why they are classified into 3 types: polar molecular solids, non-polar molecular solids, and hydrogen bonded molecular solids. We have studied last year about what is meant by non-polar, polar, or hydrogen bond. We have also studied about van der Waals forces. Don't bother if you do not recall them. We will discuss all these terms in the different types of molecular solids. Okay, first type of molecular solid is non-polar solid. What is meant by non-polar compounds? The covalent bond formed between the atoms whose electronegativity difference is 0 or almost 0. That is, they do not acquire any kind of partially positive charge or partially negative charge on them. These type of solids show some additional forces like dispersion forces or London forces, which are the weakest forces founded in van der Waals attraction. Hence, these solids are known as non-polar molecular solids. Because of weak forces present between them, they are soft and have very low melting point. You can say that these non-polar molecular solids at room temperature are either in gaseous state or in liquid form. They are brought in solid state by lowering the temperature. For example, carbon dioxide is in gaseous state at room temperature, but by lowering its temperature, it can be converted into solid form, which is known as dry ice. Similarly, iodine at room temperature, it is in the vapor form, but by lowering the temperature or putting in an under the pressure condition, it is converted into solid form. These non-polar molecular solids do not have any free electrons or ions in their compounds. As a result, they do not conduct electricity. The second type of molecular solid is polar molecular solid. What is meant by polar or polarity? Those molecules which acquires partially positive and partially negative charge on their atoms, which are covalently bonded. This positive or negative charge acquired by the atom is because of electronegativity difference between these atoms. These polar solids shows dipole-dipole forces of attraction addition to the covalent bonds. These dipole-dipole forces are also a type of van der Waals forces, but they are comparatively stronger than dispersion forces. As a result, polar molecular solids shows somewhat higher melting point than non-polar molecular solids. Polar solids are generally in a gaseous state or liquid state at room temperature. They also do not acquire any kind of an ions or delocalized electrons in them. As a result, they also act as a non-conductors, that is insulators. Example, HCl. It has a high electronegativity difference between hydrogen and chlorine. Hydrogen acquires partially positive and chlorine acquires partially negative charge on it. You can see that solid, the structure formed on your screen. The third type of molecular solid is hydrogen bonded molecular solids. These solids generally shows hydrogen bond between the atoms. What is meant by hydrogen bond? The bond formed between the highly electronegative atom containing lone pair of electron and electropositively charged hydrogen atom. This force which is created between negatively charged atom and positively charged hydrogen is known as hydrogen bond. Generally, hydrogen bond is formed only and only between nitrogen and hydrogen, or oxygen and hydrogen, or fluorine and hydrogen. That is, you can say that nitrogen, oxygen and fluorine are highly electronegative atoms containing lone pair of electrons, and hydrogen forms a hydrogen bond with those elements. Those solids are comparatively somewhat harder than polar or non-polar molecular solids, and that is the reason why their melting point in compared to all the three, it's the highest. These solids are also non-conductors. Example, H2O in the form of ice. Now another crystalline solids we are going to discuss is about ionic solids. These solids have strong Coulombic forces, also known as electrostatic forces, between their ions. This type of solids are formed when positively charged cations are attracted by negatively charged anions. In simple words, we can say that they are ionic bonds containing in them. As ionic bonds are stronger, these solids are hard and brittle in nature. Their melting points and boiling points are higher. They do not conduct electricity in the solid form, but they can conduct electricity only in the molten or aqueous state. To understand this factor, let's take an example of sodium chloride. Sodium chloride in a solid form do not contain any ions to move in it. But when they are converted into their aqueous solution, that is NaCl is dissolved in water, it dissociates itself into Na plus and Cl minus ions, producing free ions which can conduct electricity. That is the reason why it is told that ionic solids do not conduct electricity in their solid state. They can conduct electricity only in the molten or aqueous solution. The third crystalline solid is a metallic solids. They show metallic bond between their atomic kernels and delocalized electrons. What is meant by atomic kernels? Positively charged nucleus containing protons and neutrons and the inner orbital electrons together are known as atomic kernels. What is delocalized electrons? Those electrons which are considered as outermost valence electrons are known as delocalized electrons. As on your screen you can see in the diagram, by applying the force, that is by hammering onto the metal, these atomic kernels and delocalized electrons slides one over the another, and as a result they can be converted into metal sheets and wires. This property is known as malleability and ductility. These metallic solids are hard solids. They have high melting points. The free delocalized electrons present in them makes them good conductor of heat and electricity even in their solid state. That is, metallic solids can conduct electricity in their solid form as well as in their molten state. Example of metallic solids are iron, copper, silver, etc. You can take it as any metal. On your screen, the metallic bond is shown for sodium metal, which has only one free valence electron, and that is the reason why it is an exceptionally soft metal. The fourth type of crystalline solid is covalent solids. They are also known as network solids. They form strong covalent bond and are directional in nature. As a result, these solids are generally hard and brittle. They have extremely high melting and boiling points, except graphite. They also do not contain any free electrons in them, and that is the reason why they are also non-conductor of electricity. Graphite is an exceptional network solid. It is soft. It is a good conductor of electricity because of its structure containing layers with one free electron of a carbon having sp2 hybridization in it. Graphite being a soft solid, it is also used as solid lubricant. Okay, hope so. All of you have understood types of crystalline solids. That's all for today's lecture. Like previous lecture, here are some of the questions for your practice. Make sure that you practice them. In today's lecture, or in fact in any lecture, if you have any queries, feel free without any hesitation. You can contact me